For decades, we've been told the same story about Easter Island. It is perhaps the most famous cautionary tale in history. The story goes that the islanders were reckless. Driven by vanity, they cut down every single tree to move their giant stone statues. They destroyed their own paradise. And by the time Europeans arrived in 1722, the civilization had collapsed into chaos, starvation, and warfare. It was called Ecocide, a society that committed suicide by destroying its own environment. Jared Diamond's 2005 book Collapse cemented this idea in the public mind, calling Easter Island the clearest example of a society that destroyed itself by overexploiting its own resources. The lesson was clear. The story was tragic, and it was taught in classrooms worldwide. There is just one problem. In September 2024, scientists sequenced the DNA of 15 ancient Easter Islanders for the first time, and the genomes tell a completely different story. There was no population collapse, there was no ecocide. The civilization did not destroy itself. Instead, the DNA reveals a people who thrived for 500 years on one of the most remote rocks on Earth, until European contact brought the real catastrophe. Even more shocking, the DNA proves they did not just stay there. They sailed to South America and back, centuries before Columbus, carrying home 10% Native American ancestry that remains in their descendants today. This is the story of how modern science finally cleared the names of the Rapa Nui people. To understand the achievement, you have to understand the isolation. Rapa Nui sits alone in the South Pacific, 2,300 miles west of Chile and 1,200 miles from the nearest inhabited island. It is one of the last places humans ever settled. Around 1250 AD, Polynesian voyagers arrived in double-hulled canoes after navigating thousands of miles of open ocean. They found a small volcanic island, just 63 square miles, covered in millions of Chilean wine palm trees and filled with seabirds. They named it Tepito o Tehenua, the navel of the world. Within a few generations, they began their most famous work, the Moai. These were not just statues, they were ancestors. They represented deceased chiefs who would protect their descendants. Standing on stone platforms called ahu along the coastline, the Moai faced inland, their backs to the sea, watching over their communities. The scale of this work was staggering. At the Rano Raraku volcano quarry, teams used simple basalt stone picks called toki to chip away at the compressed volcanic ash. They carved nearly 1,000 moai over the centuries. The average moai stood 13 feet tall and weighed 12 tons, but some were massive. The largest erected statue reached 32 feet and weighed 82 tons, with an 11-ton redstone topknot balanced on its head. The biggest unfinished moai, still attached to the quarry wall today, would have stood 70 feet tall and weighed 270 tons if completed. For years, historians insisted they needed thousands of people and millions of logs to roll these giants across the island, destroying the forest in the process. But recent experiments proved something remarkable. Just 18 people with ropes could walk a moai upright along specially designed roads, rocking it forward in a swaying motion like moving a refrigerator. They did not need a massive, destructive labor force. They needed cooperation and physics. But the world was not ready to believe that yet. The ecocide theory started with an observation. When Dutch explorer Jacob Roggeveen landed on Easter Sunday, 1722, the island was almost completely treeless. It was just grassland and withered vegetation. Yet scattered across the landscape were hundreds of massive stone statues, some standing, many toppled. When Captain James Cook arrived in 1774, he counted roughly 3,000 islanders living in what appeared to be a marginal existence. Many moai had been knocked over. Anthropologists looked at the massive statues and did some back-of-the-napkin math. They assumed that to build such huge monuments, the island must have once held a massive civilization, maybe 15,000 people. Some estimates went as high as 25,000. So, where did everyone go? The theory filled in the blanks. The Rapa Nui must have overpopulated the island, cut down all the trees to transport statues, and then starved to death in a catastrophic collapse. Without trees, they could not build fishing canoes. Without lumber, the soil eroded. Food became scarce. Warfare erupted. By the 1600s, according to this narrative, 90% of the population was dead. It was a compelling story. It fit perfectly with modern environmental anxieties. It gave us a clear villain, human short-sightedness. Diamond's collapse warned that Easter Island showed us our own future. Universities taught it. Environmentalists cited it. Documentary after documentary repeated it. But it relied on one crucial assumption, that a massive population crash actually happened. And that is exactly what the DNA just disproved. In September 2024, a team led by Victor Moreno-Meyer at the University of Copenhagen published a bombshell study in the journal Nature. Working closely with the modern Rapa Nui community, who specifically wanted to know if the collapse narrative was true, the researchers successfully sequenced whole genomes from 15 ancient Rapa Nui individuals who lived between 1670 and 1950. The remains had been collected by European scholars in the 1800s and the early 1900s and stored in museums in Paris. Here is why this matters. Population collapses leave genetic scars. When a population crashes from 15,000 to 3,000, it creates what is called a genetic bottleneck, a sudden, drastic loss of diversity visible in the DNA of descendants. It looks like a pinch point in the genetic timeline. You can see it in the data. The team used advanced statistical modeling to reconstruct the island's population history from the ancient genomes, searching specifically for evidence of this bottleneck. The result? It was not there. There was no collapse. The DNA showed steady, slow population growth from the moment they arrived in the 1200s straight through, European contact in the 1700s. Barbara Souza de Mota, a physicist at the University of Lausanne who co-led the study, was clear about what this meant. Our genetic analysis shows a stably growing population from the 13th century through to European contact in the 18th century. This stability is critical because it directly contradicts the idea of a dramatic pre-contact population collapse. The Rapa Nui had not destroyed themselves. They had maintained a stable, resilient society for 5 centuries. This forces a question. If the population did not crash from 15,000 to 3,000, maybe there were never 15,000 people to begin with. 3 months before the DNA study, another breakthrough provided the answer. In June 2024, archaeologist Carl Lipo from Binghamton University published a study in Science Advances that reached the same conclusion from a completely different angle. His team used artificial intelligence and shortwave infrared satellite imagery to scan the entire island for rock gardens. The Rapa Nui were master farmers. In the island's poor volcanic soil, they invented a technique called lithic mulching. They would scatter rocks from the size of a golf ball to boulders across planting areas. The rocks disrupted drying winds, moderated temperature extremes, and released mineral nutrients as they weathered. In the spaces between the rocks, they planted sweet potatoes. It was ingenious adaptation, not environmental destruction. Previous studies using older satellite technology had estimated that rock gardens covered 12% to 21% of the island, enough to support 15,000 to 25,000 people. But when Lipo's team spent 5 years doing ground surveys and training artificial intelligence to distinguish between actual rock gardens and natural volcanic outcrops that had been misidentified, they discovered something remarkable. Rock gardens covered just 0.76 square kilometers, less than 0.5% of the island, just 180 acres. Based on sweet potato cultivation alone, this could support about 2,000 people. Even adding marine resources, taro, yams, bananas, and sugarcane, the island's maximum carrying capacity was around 3,900 people. Do you see what this means? When Europeans arrived and counted 3,000 people, they weren't seeing the survivors of an apocalypse. They were seeing a population that was perfectly in balance with its environment. The Rapa Nui didn't fail. They succeeded for 500 years. But the DNA had one more secret to tell, and this one rewrites the history of exploration. Buried in the ancient genomes of those 15 individuals was an unmistakable signal, approximately 10% Native American ancestry. This was not contamination from modern times. The genetic dating, using Bayesian statistical models that integrated both DNA evidence and radiocarbon dates, proved this admixture happened between 1250 and 1430 AD, centuries before Columbus, centuries before Europeans even knew the Pacific Ocean existed. This confirms what Rapa Nui oral history has always maintained. These navigators did not just reach Easter Island and stop, they kept going. They sailed another 2,300 miles across open ocean to South America, likely making contact with indigenous peoples in Colombia. They traded, intermarried, and almost certainly brought back the sweet potato, which became their staple crop. And then they turned around and sailed back. Think about that achievement. While Europe was still afraid of falling off the edge of the map, the Rapa Nui were completing trans-oceanic return voyages that European explorers would not match for another 300 years. By the 1600s, when the island was completely deforested, they no longer had the massive palm trees needed to build the large, double-hulled canoes required for such voyages. But the DNA proves that in the 1200s and the 1300s, when they still had the trees, they used them for exploration, not just statue transport. These were not primitive islanders destroying their environment. These were master navigators who crossed an ocean Europeans could not even imagine. Victor Moreno-Mayer did not mince words about what the ecocide theory really represented. He said he believes the idea of ecocide was constructed as part of a colonial narrative, the idea that supposedly primitive people could not manage their culture or resources, and that this failure almost destroyed them. But the genetic evidence shows the opposite. The ecocide theory carried a troubling assumption that indigenous people were too unsophisticated to live sustainably. It ignored other evidence, dismissed Rapa Nui oral history, and overlooked the archaeological record that had been quietly dismantling the collapse narrative for years. Yes, the Rapa Nui cut down their trees. Deforestation was real. But they adapted. They invented rock gardening. They developed water collection systems. They created social structures that allowed cooperation on massive engineering projects despite limited resources. That is not ecocide. That is resilience. The DNA study combined with the rock garden research shows the population was stable right up until the 1860s. That is when the real catastrophe arrived. So, if the Rapa Nui did not destroy their own civilization, why is the island's history so tragic? Because a collapse did happen, but it did not come from cutting down trees. It came from the ships. In December 1862, Peruvian slave raiders descended on Easter Island. Over several months, they kidnapped approximately 1,400 to 1,500 people, between 1/3 and 1/2 of the entire population. Among those captured were the island's paramount chief, his heir, and the last people who could read and write Rongorongo, Easter Island's unique script, the only writing system ever developed in Polynesia. The slavers shipped them to Peru to work in guano mines and as domestic servants. Most died within months from tuberculosis, smallpox, and dysentery under brutal conditions. When international outcry forced Peru to repatriate the survivors, 470 islanders were packed onto a barely seaworthy ship designed for 160 passengers. Before the ship even sailed, 162 were already dead from disease. By the time it reached Easter Island, only 15 of the original 470 were still alive, and those 15 brought smallpox with them. The resulting epidemic swept through the island, killing approximately 1,000 more people. French missionaries then evacuated 275 additional Rapa Nui to Tahiti and Mangareva. By 1877, just 15 years after the first slave raid, the population had collapsed to 111 people. Of those 111 survivors, only 36 went on to have children. Every single person of Rapa Nui descent alive today descends from those 36 individuals. This was not ecocide. This was genocide. The Rapa Nui did not fail. They were crushed by colonial violence. French ethnographer Alfred Métraux, who visited the island in the 1930s, called the slave raids one of the most hideous atrocities committed by white men in the South Seas. The DNA has spoken, and it forces us to retire the Easter Island warning. For decades, we used this island as a mirror for our own fears about the environment. We were so ready to believe that indigenous people were too primitive to manage their resources that we ignored the evidence of their brilliance. The Rapanui invented rock gardening to conquer poor soil. They engineered megaliths that inspire awe 1,000 years later. They navigated the vastest ocean on Earth, completing voyages that European sailors would not dare attempt for centuries. They did not overexploit their resources and collapse. They carefully managed a marginal environment for 500 years, maintaining a stable population in one of the most isolated and challenging places humans have ever settled. The tragedy of Easter Island is not that the Rapa Nui destroyed themselves. It is that they survived for 500 years against all odds, only to be nearly wiped out in 15 years once the outside world finally reached them. The DNA does not lie, and it is time we stopped telling lies about the Rapa Nui. Thanks for watching. If you enjoyed this deep dive into how technology is rewriting history, make sure to like and subscribe so you do not miss the next discovery. This is Strata Files.